In this video, I wanted to go over one problem involving applications of systems of equations. So with this problem, this is called a mixture problem because it involves mixing two quantities of solutions to get a third one. So let's take a read of the problem. So it says one candid juice drink is 25% orange juice and another is 10% orange juice. How many liters of each should be mixed together in order to get 15 liters, that is 24% orange juice? So with these type of problem, it's always very useful to draw a diagram. So let's kind of draw a diagram of what we have here. We have one container or one juice, and then we're mixing it with another juice to get a third juice. And the first one, the first solution or the first juice is 25% concentration. The second one is 10% concentration. And we want to mix those two to get a 24% concentrated orange juice. All right, so this is the percent. There's another thing we need to know, and we need to know what the amount of each is. So with the 25% concentration, we don't know how much we need. That's what we're trying to figure out. So what we're going to call that is we're just going to call it X. For the 10%, we don't know that either. That's what we're trying to figure out, right? We're trying to figure out how many liters, the amount of the 10%. So we don't know that. Let's call it Y. And for the final solution or the final orange juice, we know that we want to end up with 15 liters. So the last thing we need to know is we need to know how much of each do we have in pure amount. So what is the pure amount of each solution? So with the first one, the 25% concentration, we have X amount and its concentration is 25%. So the pure amount would be 0.25 times X. All right, so I want you guys to think about why this makes sense. So for example, let's say that we have 25% of 100 liters. How much of it would be pure amount, pure orange juice or whatever it is? And again, I just put this, I made this up. I could have put any numbers. I just want you guys to think about this one. So you should kind of think this over and you would see that you would kind of rationalize that it's, well, 25 liters is the pure amount. So one way you figure this out is you just changed this percentage into a decimal, 0.25 times 100, which is equal to 25. It's the same thing here. This was the amount, this was the concentration, the percentage. So you multiply the percentage times the amount to get the pure amount. Same thing here. This is the amount, this is the concentration. To get the pure amount, you would multiply the decimal equivalent of 25%, which is 0.25 times X. All right, so hopefully that makes sense. Let's take a look at the pure amount for the 10%. The quantity is Y, so we have Y amounts of the 10% concentration, so that would be 0.10 Y, or 0.10 times Y. And for the final pure amount, 24% concentration, and we have 15 liters of that, so that would be 0.24 times 15. And we also can think of this as the pure amount from the first solution plus the pure amount from the second solution is equal to the final pure amount in the third solution. So we have plus is equal to that. So this plus this is equal to that. We have something here that is very interesting. This is a system of equation. This is our first equation. This is our second equation. So I'm going to rewrite this. We have x plus y equals 15, and we have 0.25x plus 0.10y is equal to, if we work this out, 0.24 times 15 would give us, this would be equal to 3.6. All right. So this is our system that we need to solve. A lot of times, here's a hint for you guys. A lot of students don't like working with decimals. So what we can do is we can get rid of the decimals by multiplying by a multiple of 10. So for example, if we multiply by 100, it would cause this decimal point to move 2 times to the right, which would get rid of the decimal, right? Same thing, we multiply each of these terms by 100 to get rid of the decimal. So here's what I'm going to do. I'm going to multiply this equation, the left side by 10, and then the right side by 10. And here's what we get. The first equation stays the same, x plus y equals 15. And the second equation becomes, I'm gonna multiply by 100, not 10. So I'm gonna distribute this 100. So I get 25x plus 10y is equal to 360. So from here, to solve this, I can think about it that I can look at this and notice that they're both in standard form. So if I can get an opposite coefficients here and here, I can use the addition method to get rid of the y's. So in order to get an opposite coefficient here, I can multiply the first equation by negative 10. So that's exactly what I'm going to do. So I'm going to multiply it by negative 10 here, and then negative 10 on the other side as well. All right, so distribute. So I'm going to write it down here. That'd be negative 10x, and then negative 10 times y would be minus 10y is equal to 15 times negative 10 is negative 150. And the second equation I'm just going to rewrite. All right, so now I have opposite coefficients. I can add the two equations and eliminate the y's so I can solve for x. So I'm going to add these. Negative 10x plus 25x is positive 15x. And then minus 10y plus 10y zeroes out. On the other side, negative 150 plus 360 is 210. So we need to solve for x. We're going to divide by divide by 15. 15 cancels out with itself here. We get x is equal to 14. So this is 14 liters. Now, what we just found here is that x, which is the amount of the 25% concentration, is 14. So we have 14 right here. We now need to figure out, well, how much of the 10% do we need? And this is pretty simple, right? Because this x plus y is equal to 15. If x, the amount of the 25% concentration, is 14, then y must be equal to 1. 14 plus 1 gives me 15. All right, now if you prefer to solve algebraically, what you can do is you can think of in terms of, well, x is equal to 14 and x plus y is equal to 15. So let's plug in 14 for x. We'd get 14 plus y equals 15, and then solve it algebraically. So subtract 14 from both sides. We get y is equal to 1. So either way is fine. Just as long as you understand what you're doing, we get these answers. So some other questions, some other mixture problems are going to look a little bit different, but usually if you use this format right here, where you have the percent on top, amount in the middle, and then the pure amount on the bottom, and then from there, you can then create your two equations to create your system of equations that would usually help you solve these type of problems. All right, if that didn't make sense or you had any questions, let me know.